Okay, so we're going to look at a bunch of angle theorems that get used in geometry. We're going to learn how to use them, construct equations where it's appropriate to find missing angles. Okay, and we're also going to learn about parallel lines and angle relationships that they make as well. Okay, so this chart's important. First of all, when you're going to solve a angle question, you might find your theorem here. It also has the short forms for the theorems in it too. So the angle sum of a triangle theorem, which the short form is, so instead of writing out this definition, the sum of the angles in a triangle is 180 degrees, you could just write ASTT, which stands for angle sum triangle theorem. Okay? And all it means is that the three angles in a triangle add up to 180. Okay, so you needed to make an equation, three angles in any triangle, always add up to 180. Okay? There's also the supplementary angle theorem, which we've already used today. Short form is SAT. Parts of a straight line always add up to 180, and that should be a degree sign, not a... And that just means that when you divide up a straight line, the different parts of it add up to 180. In this case, you could write that x plus y adds up to 180 degrees. Complementary angles are parts of a right angle, and the short form is CAT. Complementary angle theorem. Parts of a right angle always add up to 90 degrees. So in this case, you can see the right angle being divided into two pieces. In this case, x plus y adds up to 90 because it's a right angle. Vertically opposite angle theorem. The short form for that is VOTE. Now I call it the letter X pattern as well. It creates equal angles, so anytime two lines cross, the opposite angles are equal, so y and x are equal, and a and b are equal. Angle x is equal to angle y, and angle a is equal to angle b by the VOTE, vertically opposite angle theorem. Exterior angle theorem, part 1. Any exterior angle is the sum of the two non-adjacent interior angles, so that sounds weird, right? Non-adjacent means doesn't touch, so this angle is exterior here is W. W is equal to the two non-touching, non-adjacent interior angles of a triangle added together. So W is equal to x plus y would be the equation you could make. This one is often a theorem that people forget. You don't need it to get angle W. Okay? You don't need it. You could figure out Z and then use supplementary angles to get W. But if you remember it, it just makes your answer quicker, I guess. We've already seen the exterior angle theorem part 2, and that is that in any polygon, it doesn't matter how many sides there is, the angles, exterior angles always add up to 360. So exterior and 360, that's the normal exterior angle theorem. So in this case, you could make the equation that x plus y plus z added up to 360. And in this picture, though, you could do A plus B plus C plus D plus E adds up to 360 degrees. So it doesn't matter how many sides the shape has, its exterior angles always add up to 360. And the short form for exterior angle theorem is EAP. Isosceles triangle theorem, ITT, says that the angles that are opposite to the two equal sides of an isosceles triangle are equal. So if these two sides are equal, then the angles opposite are also equal. equilateral triangle theorem, the angles in an equilateral triangle are all 60. Okay, so if you have a triangle where all three sides are the same, then you automatically know that all three angles are 60. And that's because angle X is just 180 degrees divided by 3, equal angles. Parallel lines are always the same distance apart. Therefore, they never intersect. When a transversal crosses two parallel lines, 8 angles are created. So in this case, 1st Street and 3rd Street are my parallel lines. You show parallel lines with little arrows. Either 1 arrow on each or 2 arrows on each show parallel lines. This would be my transversal, the 4th Avenue. But we should try to do that more straight. Very straight. There we go. This is called a transversal. Yep. Yep. So there's 3 letter patterns. There's more than that, but 3 that just have to do with parallel lines. Does anyone remember from grade 8 a parallel lines theorem? Yep.
Like how the, say, A and B would be equal to each other?
That's because of vertically opposite angles. So it doesn't have to do with the fact that we've got parallel lines. Does anyone remember?
There's the Z.
The Z, okay. So a Z, the Z pattern. So if I make a Z like this, remember that? When you make a Z, then the underarms, I call them, of the Z are equal. Okay? Yep.
There's also a constancy.
Right. So parallel lines theorem. Parallel lines theorems, I'll write them down. And the short form is PLT, and then you put in little quote marks, what letter you're talking about, so the letter Z. PLTZ creates equal angles. So an example would be angle B equals angle G in our diagram. The underarms of the Z are equal. Okay? And then Carter said there's also an F pattern, which is true. So I could make an F. So there's my transversal. And here's my F. Let me erase this part here. There's my F. And in the case of the F, the underarms of the F are equal. So PLTF also creates equal angles. Equal angles. And then the way we've got it drawn, an example would be, there's other ones, but angle E equals angle A. That's because of, so the underarms of the F are equal. So my thinking is underarms are equal. And remember, this is only if you have parallel lines. Only for parallel lines. Okay? The other one that Carter said was the C pattern. So here's a C. Now D and G are obviously not the same. D looks like it's bigger than 90 and G looks like it's a little smaller than 90, which is true. So they don't create equal angles. What does the C pattern create? Yep, Carter?
The angle here is 180.
Right. They really like parts of a straight line, okay? So the interior angles, so in this case, B plus angle D plus angle G adds up to 180 degrees. No. Angle D plus angle G is 180 degrees. Okay, so that's the C pattern. So Z and F make equal angles. PLTC make what we call co-interior angles. So those are the three letter patterns that come with parallel lines. Okay? Those three letter patterns come out of parallel lines. Now remember, we also have letter patterns that don't need parallel lines. So X is a letter pattern that doesn't need parallel lines. Opposite angles are always equal. So it doesn't matter whether they're parallel or not. And then the other kind of letter pattern that people think of is like a T, right? Which is really parts of a straight line. So these are supplementary angles add up to 180. Okay, and they don't have anything to do with being parallel, but they do, as Vanessa said right at the very beginning, they appear in this diagram. We have an X here. We have a T here. Okay, so we have an X and a T in the diagram, but it doesn't matter that the lines are parallel, whereas you can only use Z, F, or C if you have parallel lines. Okay? So those are all our letter patterns. And now we're just going to try some questions. Oh, there's just all the letter patterns explained. The Z pattern, they're called alternate angles, and here's the short form, PLTZ. Alternate angles are equal. Parallel lines F pattern, they're called corresponding angles. The C pattern, co-interior angles, they're not equal, they add up to 180. So I've just written that for you. So here the Z would mean angle A is equal to angle B. The F here would mean the underarms are equal, so angle B and angle A are equal. And here, the angles add up to 180, they're not equal. So you've got charts with all of the rules, all the short forms. And then we just have to know how to apply them to, I already did the summary over here. Okay, that's the summary. I forgot. But I wanted to write it here, so we don't need to write it again. When using angle theorems to find missing values, you need to make an equation. So find the unknown values in each angle diagram. Show your work by making equations. So it's telling us to make equations, so we have to use them. Okay. Before I start making an equation, does anyone see an angle that I can fill in? And a reason why? Actually,
The one across from us was 40 degrees.
okay, so that's 40 degrees, and see how I'm writing that in there? I'm going to write the word vote, because that's the short form for vertically opposite angles. Okay? So I can fill that in because there's this X here, and with X's, opposite angles are equal. Perfect. Now, how can I make an equation that has an X in it to figure out what X is? I have to make an equation. I can't just write what it is. How can I make an equation? Carter?
Like 60 degrees, 40 degrees is less.
Good. So x plus 40 degrees plus 60 degrees. So if I add up all three interior angles of a triangle, I'm going to add up to 180. So there's an equation I can make. The three angles in a triangle add up to 180. Okay, and the theorem that says the angles in a triangle add up to 180 is ASTT, angle sum triangle theorem. You can look that up in your chart. I don't expect you to have them memorized. You have the charts to work from. And now we just have to go ahead and solve for x. So noticing that these angles are like, subtract 100 on both sides, and we get x is equal to 80 degrees. All right, in our second example, we have to find two different angles, angle A and angle B. Anyone know how to get one of the two right now? Vesa. A. Supplementary angles. Okay, so A plus 115 degrees is 180, and that's the supplementary angle theorem, SAT. Okay, that lets me make that equation. Now I want to get A by itself, so it's a pretty easy equation, like the first day of equations. I want to get A by itself, so I'm going to subtract 115 on both sides. So I get that angle A is 65 degrees. Okay, so now I'm going to put the 65 into the diagram now because I found it. Now is there an equation I can make to find angle B? Equation. Logan. Perfect. So the three angles in a triangle, B plus 25 plus 65 degrees equals 180. And that's angle sum triangle theorem, ASTT. And then I have to get B by itself. So I can add these angles together. Oh, it turns out to be 90. End up getting B is 90 degrees. So we made an equation for each one, and then we also listed the theorem that we used. Yep.
Do you have to list the theorem every time?
You should, because really the only questions you're going to get are going to say, ask what geometric property you used. Unless it's multiple choice. If it's multiple choice, you don't have to. Okay? All right, C. What do the tick marks mean? Yep. The two, so yeah, this is an isosceles triangle, which means these two angles are equal. So I could call them each X if I wanted. I couldn't call them G because G is already in the picture. So any other letter I could call them. Anyone have an idea how I can find any? Yeah. Perfect. So I can get X by using supplementary angles. So X plus 144 degrees equals 180 degrees. And that's the supplementary angle theorem. Subtract 144 on both sides. And we get X equal to 36 degrees. So that means each one of these angles down here is 36 degrees. There's a 36 degrees here and a 36 degrees at the bottom there. Agreed? And the reason I could draw on those X's there in both was isosceles triangles actually. So now that I know those two angles at the bottom of the triangle are 36, how can I get G and make an equation? Make an equation to get G. Yep. Perfect. So the three angles in the triangle, interior angles add up to 180, that's ASPT. So G plus 72 degrees equals 180 degrees. So G ends up being 108 degrees. Okay, I'm going to give you some time to try D. Did anyone decide which one they could find first, just based on what we're doing, Daniel? X, good, because X and 84 are supplementary. They form a straight line, which would mean X plus 84 degrees has to add up to 180 degrees. So that's supplementary angle theorem, or SAT. And then you have to subtract 84 on both sides. So you get that X is equal to 96 degrees. So now I know X is 96, and I put it in the diagram. And now that I know two of the three angles in a triangle, I can make the equation that Y plus 46 degrees plus 96 degrees has to add up to 180. And that's the angle sum triangle theorem, ASTT. So the angles in a triangle add up to 180. So that's going to end up giving me 46 and 96 is 142. And then I subtract 142 on both sides. Which means that Y is going to turn out to be 38 degrees. And then I've got both of my angles. Okay. Next question. You want to get little g there, so I'll give you a minute. Okay, so I see lots of people adding this angle in here. Okay, that's good. Don't call it G. So X plus 130 degrees is equal to 180 because they're supplementary angles, so SAT. And we end up getting X is equal to 50 degrees. So now I know that angle in there is 50. And then once you know two out of the three angles in a triangle, all three of them add up to 180. So G plus 70 degrees plus 50 degrees gives you 180. And that's angle sum triangle theorem, ASTT. And then we can add those two together. Subtract. get that G is 60 degrees. So the thing that you have to always keep in mind is some of the angles that you're not asked for and you're not given, you may have to find using an angle here in order to find one that you do have to find. Okay, this one's an EQAO. Find the measures of P and R, complete the chart. So you have to say what property you use as well as showing any calculations that you end up having to do. So there's the diagram they were given that year. Notice that there's these arrows, which means these lines are parallel. Anyone have an idea? Bit of a stinker, this one. Anyone have an idea? Anyone? Nobody? No idea? Lucas, do you have an idea? Nope. Nobody? Yes, Vanessa.
Using ASP
Yep.
to get the third angle of that triangle.
Which happens to be what? T. Good. So you can put a P in there by using both. They're opposite angles, right? Everybody good there? William, you understand why that angle is the same as that angle? They're both P. The X. Okay. That means now that you can find P by doing P plus 42 degrees plus 65 degrees. So the three angles in a triangle add up to 180, and the property we used was ASTT. If you can write that down, you don't forget anything else down there. Okay? Now I still have to find P, so I have to add these angles together. Oops, it's not 67, it's 87. Nope, 107. And then subtract 107 on both sides. And we end up with P is 73. So that goes in our value side. Okay, so P turns out to be 73, so we can put that in our diagram now. Any ideas? Remember, there's parallel lines. Any ideas how I could get R? Julian?
It's really wrong, but would it 73 be not R?
Right. Okay, so that's perfect. So that's by the F pattern. So I'm going to draw that in here. So here's an F. So in an F pattern, the angles under the arms are the same. Okay, perfect. All right, so that gets to go into our diagram because of PLTF. And then how does that help me find R? I can use supplementary angles. So to get R, I would do that R plus 73 equals 180 degrees. Perfect. So that's SAT, supplementary angle theorem. And then I would need to subtract 73 degrees, which would give me 107 for R. Perfect. So we did need to use one parallel angle one, right? We had to use the PLTF. To find P, I didn't have to use any parallel things at all. I just used the X, which was opposite angles, and angles in a triangle. Okay? But to get R, I did need to use parallel lines there now. Good. All right, take a look at the next one. Another EQAO question. Solve for X and Y, justify your reasoning. I'll give you a little chart, your angle theorem. So we got parallel lines going on, we've got an isosceles triangle in there. We've got an isosceles triangle here. We also have parallel lines. Does anyone see a letter pattern we could use to get X? Yep. Which one? C, perfect. Okay, so I'm going to use a C pattern here. So there's my parallel line, transversal, parallel line. And the C pattern aren't the same, they add up to 180. Okay, so I can do X plus 104 degrees equals 180 degrees. And that's because of PLT, parallel lines theorem, C pattern. Co-interior angles add up to 180. Yep. You could also do F. Yeah, I guess, oh, I see. So if he's doing, no, I don't think he's, yeah, I don't see the F either. How do you spell F? Here?
Yeah.
Okay, but how do you know that angle?
You can figure it out.
5?
How? There's no other angles to figure it out with.
You can also extend the line. You can also extend it.
Extend this one?
Yeah, the 104 is the same.
Yes, why can't you just
And so,
Line.
You could extend the line, I guess, but the one that's obvious is C, but you could, as long as you show your thinking, okay?
But I'm looking for the letter F somewhere. I was
Me
like,
too.
So that is what you have to look for. That is,
No, look at it. I got like the
yeah,
X is like an F or something. Like there was supposed to be an F on the
oh.
So
there's no F.
And then
We're on 2 different pages there, so we.
it's so much steps. But 180 miles okay, and then doing
So that means X ends up being 76 degrees. Hello, Mr. Jago. So that means I can fill that into the diagram. How about a way to get Y? Vanessa,
supplementary angles with the 104.
agreed. So I can't call it X or Y, so I can call this little angle there Z. So Z plus 104 degrees is equal to 180. And that's supplementary angle theorem. So that gives me that Z is 76 degrees. So this angle here, try to make that a bit smaller in there. Turns out to be Z, but also 76 degrees. Now, if it's an isosceles triangle, what does that make this angle? 76 as well. Okay, so the two angles opposite the same length sides in an isosceles triangle are the same. So both those angles inside this triangle here, this red triangle I'm going to draw, are 76, and the other angle is y. So I can make the equation y plus 76 degrees plus another 76 degrees has to add up to 180 degrees. And what did we use there? We used isosceles triangle theorem and the sum of the angles in a triangle theorem. And I showed my work up here for how I got 76 using supplementary angles. So I'm going to add up the 76 degrees together and get 152 degrees. Degrees. And then you have to fill it into the chart. Okay, look at the next one. Find the value of A. I feel like you can all do that one. That's Nielsen triangle here. They all end in A, so they're like terms. Remember, there's a 1 in front of that one. So there's 6 A's. So A ends up to be 30 degrees. And that's all we asked you for. Clear 4 in front of it. And that's the answer. And then part B though asks you for something different. Okay, it wants the measure of angle B. So angle B is up here. Angle B says it's 2 times A, which is 2 times 30 degrees, which is 60 degrees. Next one, wheels of fun. A Ferris wheel has 6 sides of equal length. So ignoring the little seats that are there to confuse you, we have this shape here, plus the inner spokes. We've got a hexagon, right? 6-sided with equal length, so it's a regular hexagon. And then the exit ramp of the Ferris wheel is in the shape of a trapezoid. The important thing about a trapezoid is that you've got a set of parallel sides there. So that's the definition of a trapezoid. 2 sides are parallel. And then it says, it shows you the 20-degree angle in there as well. What are the values of X and Y? Use geometric properties to justify your answer. Any ideas? It's a tricky one. Yep.
Oh, with Y, you can use P06.
Yes, you can. Very good. Okay, so to get Y, I can use the C pattern. So the co-interior angles add up to 180. So I would go down to my Y column in the chart, and I would write out Y plus 20 degrees is equal to 180 degrees. And that's by P, parallel lines theorem, C pattern. So the underarms of the C add up to 180. Okay? So once you know that, you know that y is going to be 160, because you're going to subtract 20 on both sides. Sorry, I'm going to subtract 20 on both sides. Get 160. So there's half our question done. Once you've got that 160, you want to put it into your diagram. Because often adding angles that you find helps you figure out what you need to know in order to get the question. So we now know that this piece here is 160. And does anyone see how it's going to be possible for me to end up getting x? Yeah?
I don't remember the interior angles in the film.
Right, so if I find that angle, oh, I want to do it in a different color. If I find that angle and call it Z, then all three angles would make a circle, so they add up to 360. You see that? So I have to find that interior angle Z. All right? And how did you do that, Carter?
I got this film in the back.
Okay, so sum is going to be 6 minus 2 times 180. Which is 720 degrees, so we use that sum from this morning, okay? And then, so angle Z, Carter said is going to be the total sum, 720 divided by 6 equal angles, which ends up giving you 120. And I can put that into my picture now. So out of this circle I'm forming around this last bucket seat, I've got 160 degrees here and 120 degrees here, and the only piece missing is x. So anytime you make a circle with adding your angles together, they add up to 360. Any questions so far? Yeah?
Do we have to label like the wheel, or can we just write it in the box?
You can just write it in the box. Yeah. If it helps you to see the angles, put them on your diagram. If it doesn't, then make sure you put it into the chart. Some people think it makes it messy. Yeah, that's fine. Okay, so I'm going to make my equation is going to be that x plus 160 degrees plus 120 degrees equals 360 degrees. And my reason is that a circle, or a full circle, has 360 degrees. And then I'm going to combine or add together my 160 and my 120. Subtract 280 degrees on both sides. So you get 80 degrees. And make sure you put it on your chart slide as well. So the year that was on EQAO, it was a stumper. The lines inside the carousel confused people. The little seats confused people. Not remembering that a trapezoid had two parallel sides. This one was a stumper. So sometimes like subtracting stuff out of the picture actually helps you, and reading the question really carefully as well. So if I was really stuck on this one, I might have just redrawn the outside of the shape. And looked at it like this instead of with all the stuff inside, and that might have helped me. Okay, and then shown where X was and where Y was. Okay. All right, consider here the diagram below. What is the value of X? This was also a stumper the year was on. There are parallel lines. Yep. Yes, you may. Anyone think they've got any ideas that would help us to get? Yep.
Since the lines are parallel, the angles are going to be the same.
Which angles?
So the 80 degrees is going to be the same for in the right triangle in the top right corner.
No.
Oh, wait, no.
Because that's not straight up and down.
Oh,
Do you see that? Okay.
I was looking at it.
Yes, I see that too. And then a lot of people did do that, but you see that. So here's. I don't know. There we go. So here are my parallel lines now. This one and this one. And the green one is my transversal. Does that help me with anything? So where could I put the 80 degrees in other words? Where could I put the 80 degrees? Can I make a Z? Yes, I can. But that puts the 80 degrees here, right? Does that help me towards getting X?
Wait, what is that?
That's 80. It's a Z pattern, so the underarms of the Z are the same.
You could find
Yep.
the supplementary to what?
Yes. Okay. So there's a parts of a straight line. So there's 80. X is already used, so I can call that angle there Y. So Y plus 120 degrees adds up to 180. So you end up getting Y equal to 60. So now I know this one's 60 and this one's 80. How does that help me towards getting X? Yep. The STT gives me this angle here, right? So I've already used Y, X is already in the picture, so this angle here is going to be Z. So Z plus 80 plus 60 is 180 by angle sum triangle theorem. So that ends up giving me 40 degrees for Z. And finally, I can find X using supplementary angles now. So I know little z there is 40, so X plus 40 adds up to 180 because they're supplementary. So X is going to turn out to be 140 degrees. $140. Yep.
I got the same answer, but I did it a very different way.
Yeah, there's lots of ways to do it as long as you didn't break an angle code. So what did you do?
I took the 140 and I got the supplementary for it. And so,
This one here?
yeah, so
Yep.
60 there.
Yep.
And then
Crossed it.
that makes the third angle. Over there,
Oh, okay, yep.
40.
Yep.
And then, so the one supplementary to X over there, if you haven't extended on to the right of it, kind of,
Yes.
is 40
Yep. By the
by the,
F pattern,
yeah, the F pattern.
and then 180 minus 40. Something. Good. Good. Excellent. All right. Here's another EQAO. Find the value of X. I'll give you some time. Okay, because it's isosceles, I see lots of people putting 76 degrees in there. I can't call the top angle X because X is already in my picture, but I can call it Y. So I can get that top angle by making this equation. The angles in a triangle add up to 180 degrees. .28 degrees is Y, so that angle up at the top is 28 degrees. How does having that angle up the top help me to get X? Amelia?
You can use it anywhere.
Yes, so would my equation be? I got 28.
Or 20.
Yeah.
Equals,
Good. So then Amelia was looking at this whole big triangle as her second triangle, right? So she knew she's got to find X, this is 90, and the one at the top was 28. Okay? And that's angle sum triangle theorem as well. So you end up getting .52 degrees for X. Okay, so we used a lot of theorems there, isosceles and ASTT twice in order to get X, but we got it. All right, our last two. Consider the diagram below. What is the value of X? And notice the arrows meaning parallel lines. May or may not need to use that in order to get the answer. So again, that's a good strategy for these questions if you're stuck is just find what you can find. Okay, so I see there's a triangle where I know 2 out of the 3 angles, so I know for sure I can find the third one. Okay? So if you're stuck, rather than just trying to wait for the whole thing to come to you, try to just think, what could I find first, or what can I find, what do I have the ability to find, and then go from there. Even though in this case I don't actually have to find this third angle, if I recognize this Z pattern here, what does that Z pattern allow me to do? Yep.
You get the angle and X.
Good. So these two angles are the same by the Z pattern. Okay, PLTZ. Parallel lines theorem Z makes those equal. And then to get X, I've just got a supplementary angles. So X plus 61 ends up being 180. And that's supplementary angles. $119 degrees
For what?
for x. So what is the value of x? So therefore x is 119 degrees. And then the last one is another EQAO with the chart format again.
That was my thought, I'm sorry.
Okay. Use geometric properties and algebraic reasoning to find the values of x and y. So I'll give you some time. It's good. So I'm either seeing a formula or I'm seeing people going, I can make 3 triangles. 3 times 180 gives me the sum of the interior here, or they're using the formula that the sum is 5 sides minus 2 times 180 degrees. Gives me 540 degrees. So somewhere you got to show how to get that the sum of the interior angles of that 5-sided shape is 540. Okay? So that's that formula from this morning. Sum equals number sides n minus 2 times 180 degrees. Okay? Some people just know for 5 sides it's 540. Okay? But once you get into the 15 sides, you probably have to use the formula. Don't just know it in your mind, in your heart. Once you got that 540, all of the angles, interior angles, add up to that. So it's easy to make your equation. X plus x plus x plus 100 degrees plus 100 degrees equals 540 degrees. So there's your equation. All 5 angles add up to 540 degrees. Okay, all 5 angles add up to 540 degrees. Then we can collect these ones and get 3x and collect these ones as well, plus 200 degrees equals 540 degrees. Chalk the 200 degrees on both sides. Divide by 3. $113.3 degrees. That's approximately, in this case, 113.3 degrees. So I put that in my chart as well. And my justification is that angles in a pentagon, or you can just write 5-side, 5-gon, pentagon, add up to 540 degrees. That would be your justification by using a geometric property. I forgot the point 3. Okay, so that's how you get x. Y is a different story. It's part of a quadrilateral, a 4-sider. And we know that this bottom corner is 90 degrees because it has that right angle symbol. Who knows how many degrees are in a 4-sided polygon? Logan? 360. So all of those angles added together pass that up to 360. Okay, so it's easy to make an equation then. Y plus 85 degrees plus 90 degrees plus 70 degrees adds up to 360. So that gives you 245 degrees. So that ends up giving you y equal to 115 degrees. Fill it in your chart as well. And then that reason is that angles in a quadrilateral, that's what you call a four-sided polygon, quadrilateral, add up to 360 degrees. Okay, so when you're doing practice 37, make sure you have your list of reasons handy, okay? I'm going to shorten it down what you have to do a little bit from this one as well. So I want you to do number 1, A, B, C, and F. Q, 4, and 6. Okay? So just circle those ones on this practice. The answers are at the bottom. And I'll post those solutions. And once you're done those, you also have today's assignment in your bag of goodies. And you can start that.